Hi, this session is on substitution, which involves evaluating expressions. Now, substitution means replacement. This involves replacing a pronumeral with a given number. And just like in sports, a substitute replaces another player on the field. So it means replacement. Now, the other keyword, evaluate, or in this case, evaluating, as we have looked at it before, it means to show the value, to find the value. What is it? What's the actual number, the answer? Now, something to keep in mind, I call it the substitution law. It's not actually a law, I've just made it up. But sometimes with substitution, you should always substitute with brackets, okay? Especially when you have negatives. Otherwise, first write the term in expanded form. So here we've got a squared, and it becomes a times a. So we're going to see examples that relate to this, but keep in mind, a lot of times I will be substituting with brackets. Sometimes it doesn't make a difference, so you don't really have to, but keep in mind it can be very important. Okay, so I've broken up the questions relating to substitution into different, types. So the first section is substituting with whole numbers. So write this section down, and we'll look at some examples relating to this. Okay, so these expressions that we'll be doing involve addition and subtraction. So here are our two questions. We've got, if A is equal to 5, B equals 2, C equals 3, can you now evaluate or find the value of this one here, A plus B, and number 2, C minus A minus B? So have a go first. So replace those variables or those pronumerals with the numbers given and see what you get. Okay, so for question 1, we have A plus B. So A, it tells us, is 5, and B is 2. So I'm going to replace A, so equals. So A is 5. Now in this case, we don't really have to use brackets, but what I mean is I'll put the 5 in brackets. So instead of A, I now have 5 plus B in brackets, which is 2. We can see they didn't have to be there, so we still have 5 plus 2, and 5 plus 2 is 7. So our answer for this one in evaluated form is 7. Okay, our next question, we have C minus A minus B. Now remember, all of our values here are positive, so we don't have to worry too much about negatives. So replace C with, in this case, 3. So 3 minus A, which is a positive 5. So 5 minus B, which is 2. I didn't use brackets because I can see that I don't really need to. And now make sure you work from left to right. Don't go 5 minus 2 first. We first go 3 minus 5. If that helps, put brackets around the first step. 3 minus 5 is negative 2. And then minus 2. And minus 2 minus 2 is a negative 4. Okay? So be careful with your negatives. Okay, our next examples involve expressions that have multiplication. So we can see A and B would mean A times B. So we have to know these skills in order to work out and find the value. So once again, A is 5, B is 2, C is 3. Replace the variables for each of these questions and using substitution, and then we can work it out. So have a go first. Okay, so with questions like this, if it helps, you can write it out like this. It's really saying A times B, and we know times comes first, so we can put brackets around that, plus C, and then replace what we have. So A is 5 times B, which is 2, plus C, which is, it tells us, is 3. And using order of operations, BIDMAS, 5 times 2 I know is 10. So I'm left with 10 plus 3, and 10 plus 3 is 13, and we're done. Another way to show working out would be to use brackets, so as in substitute with brackets. So A, I would have 5 in brackets, times B, which is 2. So we know 2 brackets sitting together. There's a times in between them. And then plus C, which is 3. So 5 times 2 is 10, and 10 plus 3 is 13. So if you did it that way, it's also correct, but either way is fine. Okay, so our next question, we can see what we have here. There's a lot of multiplication in this one. So we've got basically 4 times B times C over here. So I'm going to use brackets. So 4 times B, which is 2, times C, which is 3. Take away 2 times A, and A is 5, plus A times B. A is 5 times B, which is 2. Now, if you prefer writing down the multiplication symbol, you can, but it's good to get used to other ways of showing working out. Okay, we know multiplication comes first. So 4 times 2 is 8, and 8 times 3 is 24. Don't forget to bring your takeaway down, takeaway. And then we've got 2 times 5 here. So 2 times 5 is 10, plus, and then of course 5 times 2 is also 10. Okay, left to right, 24 take away 10 leaves me with 14. And 14 plus 10 gives us 24. So hopefully that was your final answer. Okay, our next examples involve expressions that have brackets. So we can see questions 5 and 6. There are brackets in our expressions. So let's learn how to substitute with these types of questions. Okay, so let's start off by replacing our pronumerals or variables with the following values. So A, once again, is 5 outside the bracket. So write your bracket down. B is 2 plus C is 3. Because we already have brackets in here, I won't use brackets when substituting because I can see I don't need to. And now when it comes to order of operations, we do what's inside the brackets first. So in the brackets, we have 2 plus 3s. So we end up with this 5 bracket, 2 plus 3 is 5. And now remember that important skill that we have learned. If you've got a number and a bracket and nothing else, there's an invisible times there. That is saying 5 times 5, which is 25. Okay, our next question once again has brackets, and let's replace everything that we have. Now just remember that's saying 4 times B and 7 times C and 4 times A. So I might use brackets for this one. Okay, so I've got 4 times B, which is 2. Okay, and then my big brackets here, 7 times C, so 7 times C, which is 3. Take away 4 times A, which is 5. And then I close my brackets again. Okay, so we can see there are a lot of brackets, but we can still work with this. So outside I've got 4 times 2. So 4 times 2 gives me my 8. And in my other brackets, I've got 7 times 3, which is 21. Take away 4 times 5, which is 20. So once again, work inside the brackets first. 21 take away 20 leaves me with 1. And 8 times 1 is just 8. Okay, the next type of expressions we have involve fractions. So you can see questions 7 and 8, there are fractions given to us. Now, we just do the exact same thing, and this obviously will involve your fraction skills. Okay, so let's replace our variables. We have A on top, and A, they tell us, is still 5, so 5 over. And then B plus C, B is 2. Now I'm going to put this in brackets to emphasize that we must do this. So 2 plus C, which is 3. Now when it comes to examples like this, and you have a fraction and just say on top or bottom there's a plus or a takeaway, you must calculate in this case 2 plus 3 first before doing anything else. Okay? So 2 plus 3 is 5. So I end up with 5 over 5. And 5 over 5 leaves me with 1. Okay, for this next example, once again we have fractions. So let's replace everything step by step. So here I've got AC. Okay, remember it's saying A times C. Please do not write A is 5 and C is 3, because we don't have 53, we have 5 times 3. Because sometimes students make that mistake. So 5 times 3 over 30. I'll put brackets around this because I know they belong together, and I've got to calculate that first. And then 4 plus B, once again brackets, 4 plus B, instead of B, once again B is still 2, over 30. All right, so now 5 times 3 is 15. I've got 15 over 30, plus 4 times 2 is 8, and I've got 8 over 30. Now, because my operation is addition, I have to add these two fractions here, okay? And we can see that they already have given us the same denominators. So that's step's done for us. So let's add 15 plus 8. So my next step, I will have 15 plus 8 over 30. They both have the same denominator. Equals, and 15 plus 8 leaves me with 23 over 30. Now, that's not, it's a proper fraction, and I can't simplify that any further. So I stop there. Sorry, I apologize. Over here, 4 plus 2 is actually 6, not 8. I went 4 times 2 in my head. So I'll just change that. 15 plus 6. So 15 plus 6 is 21 over 30. And now, can I simplify 21 over 30? Yes, I can. I can divide them both by a factor of 3. 21 divided by 3 is 7. 30 divided by 3 is 10. So you should have had 7 over 10. Our next example will have expressions involving the radical sign. Okay, so if you have forgotten what the radical sign is, it just involves this symbol here. We could have, for example, square root, where there's an invisible 2 there. In this example here, we have the cube root, because we can see they've shown us a power 3 just over here, just there. So that's why we know it's the cube root. Okay, so when it comes to these types of examples, you first work out what is underneath the radical sign. In this case, the cube root. You must do that first. You can see the AC plus 6B, they are all under the same radical sign, so we calculate them all together. If they were under different radical signs, then we do it separately. Okay, so I have the cube root of A times C. So A is 5 times C, which is 3, plus 6 times B, and B is 2. Make it a bit longer. Okay, if you want to write times, once again, that is absolutely fine. So cube root of, so 5 times 3 is 15, plus, we do times first, and then 6 times 2 is 12. And now we must add the 15 and the 12 together before we can look at the cube root. Okay, 15 plus 12 leaves us with 27. So now I have the cube root of 27. Now I have to do one more thing. This involves using your radical sign skills. Just like the square root of 4, we know is 2. Everyone usually knows this one. So always go back to this if you ever forget. Why is the square root of 4 equal to 2? That is because there's an invisible 2 out here, and it's saying a number times itself twice, the same number, to give you 4. What is it? So this symbol is asking you a question. Can you think of a number times itself twice to give you 4? In this case, we know it's 2 because 2 times 2, same number times itself twice, gives us 4. So we can work that one out. So this one here is asking us a number times itself 3 times to give you what? To give you 27. So let's start with small numbers first because they get large very quickly. If I said, okay, maybe it's 2. Let's check. 2 times 2 times 2 leaves me with, 2 times 2 is 4 and 4 times 2 is 8. Did I get my 27? No. So it can't be 2. Let's try 3. 3 times 3 times 3. So 3 times 3 is 9 and 9 times 3 is, yes, it happens to be 27. So my answer is, my final answer, I'll squeeze it here, is 3. So you should have had 3. If you had 9, you made a mistake because you would have thought you saw 3 and 27 and you may have done division. We don't divide with the radical sign. We always read that question in your head. A number times itself 3 times to give you the number under the radical sign. In this case, it was 27. Okay, our next section involves substituting with negatives. So we have been substituting with positive numbers like the 5 and 2 and 3. They were all positive. Now let's try and do this with negatives. And this is where substituting with brackets can be very, very important. Okay, so we can see we've got now A is equal to a negative 3. So we've got a negative value. B is a positive 10. And C is also negative 4, a negative value. And it asks us to find the value of back to question 1 now. So we've got 3A plus B. And then question 2 is this one here. So have a go first and be careful with your negatives. Okay, so let's replace the A. In this case, it's a -3 and the B is a +10. So we have 3 times a -3 plus B, which is +10, so just 10. Now we do times first. So 3 times a -3, we know a positive and a negative make a negative. So we have -9. 3 times 3 is 9 plus 10. Now, -9 plus 10, I'll go back to the positive end. So the difference between them is a 1 and it will be a +1. And you should have had 1. Okay, let's try our next question. So let's replace our pro numeral. So C is -4. Now be careful with your negative. So equals, we've got -4. There's still a minus here. I'll change my color. So don't forget to bring that minus down from the question. So take away, bracket, 4 times A. So 4 times A is a -3. Bring that takeaway down as well. Take away B, which is a +10. And we close our bracket. Okay? So just be careful. You make sure you write down everything that's in the question as well. All right, so now let's work out what's inside our brackets because we know brackets comes first. So we've got -4 still there. Minus is still there. In these brackets now, I've got 4 times a -3. 4 times -3 is a -12. And I've got bring this down, -10. Just do one step at a time. I am still working inside my brackets. -12 minus 10. So basically, when they're both negative like that, you just add them and add the negative. So to be a negative, what's 12 plus 10 normally? It is 22. And there we go. Now, at this point, just be careful. We see now, these brackets don't have to be there anymore because there's no power outside the brackets. We've worked out everything inside. So imagine they weren't there. These two negatives are actually sitting together. Oop. So they became a positive. Or become positive. So we have -4 now plus, I don't have to put my brackets anymore, plus 22. Okay, so you should have had that. And -4 plus 22, well, because one's a negative and one's a positive, to work this out, what's the difference between them? So in other words, just subtract. 22 take away 4 is 18. And let's check. Because 22 is larger and it's a positive, we always look to the left to check if it's positive. My answer is a positive 18. Okay, our next expression involves expressions with powers. So we can see we have, in this case, a squared, so a to the power of 2, and b squared, which is b to the power of 2. And we're still going to be using the same values for a, b, and c. Now, this is where it's really important to remember that when substituting negative numbers into expressions, you must substitute with brackets or first write the expression in expanded form. So I'll show you what I mean by that. But please have a go first. Now, before we do this question, I just want to show you something that's really important. If you had a question like this, -2 to the power of 2 squared, and another one like this, bracket -2 to the power squared, and you were asked to calculate each of these, you would get different answers because of those brackets. So with the first one, we can see how we have 2 to the power of 2, and that negative is just sitting there by itself. So it's not actually being squared. So my answer would automatically be a negative. So I write the negative because I can see it's just sitting there. And then I've got 2 squared, which is 2 times 2. And I can see I've still got 1 negative. 1 negative means the whole thing's a negative. And 2 times 2 is 4. Okay? So we've got a -4 for this one. Whereas number 2, even though it looks similar, these brackets make a big difference. We can see that negative is also now being squared. It's in the brackets. So that 2 is saying 2 negatives, and also it's saying 2 squared. So in other words, if we wrote this out, we would have -2 times -2. And 2 negatives make a +4. So we can see we've got 2 very different answers. They both are still 4, but one's a negative and one's a positive. That's why brackets become very important with questions like these. Okay, so one way to work this out, I will show you 2 different ways. The first way a lot of students do is they first go, okay, a squared is a times a, and then they go plus, they know times is first, plus b times b, and then they replace what they have. So a squared, with a is a negative 3, so we have minus 3 times minus 3. So we've got our two negatives there, plus b, which is a positive 10, times a positive 10. Okay? And they work it out this way. Minus 3 times minus 3 is a positive 9, plus 10 times 10 is 100. Add them together and we're left with 109. Now, doing it this way is absolutely fine, but sometimes questions do get more complicated and larger, and then having all this working out might get you confused. So the way I do it is this. Make sure you substitute with brackets. So that a, I replace it with, in brackets, a negative 3, and I square that, plus b is a positive 10 in brackets, and I square that. So you can see doing it this way, you have less working out, and it can make things a lot easier with harder questions or more complicated questions. So like we saw before, minus 3 in brackets squared is saying minus 3 times minus 3. So two negatives make a positive, and 2 times 3, two threes, or 3 times 3 is a 9. So we have 9 plus, and then that's just saying 10 squared. So in this case, the brackets don't really have to be there. So 10 times 10 is 100. And once again, we have our 109. Okay? So either way is fine, but get used to using brackets like this because it makes it easier later on. Okay, our last example involves substituting with fractions. And once again, don't be scared of fractions. As long as you're confident with your fraction skills, you'll be fine. Okay, so I have some new values for A, B, and C. A is now negative 2, B is 5, and C is negative 1. And I'll just write up a question for you. Sorry, I just remembered I have to give you some fractions for this. B can still be 5, so C is a half. And this time A, I'll make it a negative 2 over 3. So just change those values, sorry, because we are now substituting with fractions. Okay, try the first example. We have A plus B. So all we're going to do is replace A. A is a negative 2 over 3, or negative 2/3, plus B, which is a half, a positive half. And now all we have to do is use our fraction skills. In this case, we want to make the denominators the same. So times by 2 on this side, times by 3, times by 3. Don't forget there's a negative there, so I have a negative. 2 times 2 is 4 over, in this case, 6, plus 1 times 3 is 3 over 6. So they both have a common denominator of 6. Now, this step here is really important when adding negative and positive fractions. And that is, make sure you write it under the same denominator. We've learnt this in term 1. Just to recap, we have a 6. They both have the same denominator as 6, so write the 6 once. And now that negative here, it's really saying a negative 4. So we just write it so it's clear to us. A minus 4 plus 3. Because a lot of students forget that negative or don't know what to do with it. So writing it like this, so make sure, I've got an arrow here, make sure you include this step, please, when you've got fractions like this that involve negatives. Now, minus 4 plus 3, that gives me a negative 1 over 6. Now, there's nothing else I can simplify. You can leave your answer like this, that's still correct, but usually that negative, we write it in the middle of the fraction, just like that, because it's telling us the whole number is just a negative number, okay, a negative decimal or fraction. Okay, this is our last question for this session. Have a go at this one. It might confuse you at first, but it's actually really easy. All right, so we have A over C. Now, we can see that A is 2/3. So I'll just write a bit smaller so I've got room. So A over C. So I've got A, which is, it's a negative 2 over 3, over, so there's my fraction line in the question, so A over C, and C is a half. Now, students write this down, and this is correct. I'll put equal sign just here in the middle. And they look at this and they think, what on earth am I supposed to do? And they just leave it there. They get stuck. Now, just remember that one important thing that we know, this vinculum, the fraction line, which we know is a vinculum, means what? It means division. So just write it as division. So what I mean is we'll have this, negative 2 over 3. Instead of writing that whole fraction line, just write divided by, and we've got a half. Now, does that look much easier? Okay, so I'll just make more room up here. Okay, so now we can work with this. We know our fraction skills. When we divide, we must turn division into times by flipping the right-hand side. Whoop. So my arrow just went. Okay, so I've got now minus 2 over 3 times 2 over 1. Now try and simplify before you multiply. Nothing I can simplify. Don't forget that negative's there. So we should have actually double checked that at the beginning. Because we're dividing and there's one negative, the whole thing will be negative. Okay, don't forget that. And now just multiply your numerators. So 2 times 2 is 4 over 3 times 1 is 3. And we end up with a negative 4 over 3. You can turn it into a mixed fraction, so it's a negative still. 3 into 4 goes once. Remainder 1 over 3. Remember, when doing this, the denominator never changes. 3 is still 3 there. Thank you.